Hi, we are CCTeam, and our report topic is about the Titanic. We apply machine learning techniques to predict the factors that contributed to the survival of passengers. This is the content of our report. Part 1, Introduction. First, let's introduce the Titanic Survival Prediction Report. We will get a lot of information about the passengers, such as the passenger's gender, name, port of departure, cabin class, ticket cost, ticket number, etc. We need to use this information to predict whether these passengers will survive the accident when the ship sinks. Part 2, Data Analysis. Among the number of survivors and their gender, we found a significant gap between the proportion of survival and death. The death rate is about 60%, while the survival rate is around 40%. Further observing the relationship between gender and survival rate, we found that the survival rate of females is several times higher than that of males. Perhaps, like in the movies, women and children were given priority to board the lifeboats during evacuation. Through the analysis of the relationship between age and survival rate, it was found that younger individuals have a significantly higher survival rate. Further analyzing the relationship between fare and survival rate, it can be observed that passengers with lower fares have a much higher death rate. Next, by analyzing family data, we created a new field called family size by adding the number of parch and CCTeam. It was found that the smaller the family size, the lower the survival rate compared to those with a larger family size. Part 3, Random Forest. Let's introduce random forest. The general method of random decision forests was first proposed by Titanic Ho in 1995. Random forests is an ensemble learning method used for classification, regression, and other tasks, operating by constructing a multitude of decision trees during training. For classification tasks, the output of the random forest is the class selected by the majority of trees, while for regression tasks, it returns the mean or average prediction of the individual trees. So how to generate random forest? First, end samples are drawn from the training set with replacement, allowing duplicates. For example, if we have 1,000 records and extract 100, some records may appear more than once. Next, K features are randomly selected as decision factors, so each tree only uses part of the features. This process is repeated m times using bootstrap sampling to generate m decision trees. For classification tasks, majority voting determines the final result, while for regression tasks, the average of all tree outputs is used. Let's talk about random forest advantages. First, for many kinds of data, it can produce high accuracy classifiers. Second, which training data and features each tree will use are randomly determined. Third, improve the decision tree overfitting problem by adopting the voting mechanism of multiple decision trees. Fourth, each tree can run in parallel during the training or prediction phase. Part 4, Base Model. Inextensive. The data set of Titanic is very small with only 891 records. Therefore, the problem that SVM and KNN are criticized for being very inefficient in larger data sets will also be relieved because of the small data set. However, due to the random forest, the characteristics of its parallel computing are good when the data set is small or large. Therefore, we choose random forest in generality. And in preprocessing, the data must go through a preprocessing before being fed into the model. SVM and KNN use distance as the basis for hyperplane segmentation and neighborhood voting, which involves many procedures and increases the risk of poor processing. On the other hand, random the forest uses the impurity function to divide the samples, so normalization or standardization is not required, which simplifies the steps in modeling. Next we'll introduce standard scalar and min-max scalar. If you are a friend who wants to use KNN and SVM, the most popular ones are standard scalar, which divided by the standard deviation after deducting the average value, and min-max scalar, which divided by the maximum and minimum values, and someone has tested two in the discussion area on Kaggle. It is basically case by case, maybe try both to see which one can have a better LB score, but if you want to compare the pros and cons. Benefits of standard scalar is, after processing, they all conform to the normal distribution, mean equals 0, standard deviation equals 1, which is good for most algorithms. And disadvantage is, if your feature is originally the kind with many zeros and few ones, sparse, it will not be sparse after processing. Once the amount of data is large, the advantage of faster calculation will disappear. And let's talk about the benefits of min-max scalar. As mentioned above, the sparsity of the features can be maintained while controlling each feature to maintain equal weight. And disadvantage is, since the distribution is not transformed after processing, it must be carefully determined whether the algorithm will perform poorly because the data distribution is non-Gaussian. Part 5, Feature Engineering. Next, in data processing we have to deal with some of the features mentioned before. For example, the data in the field of name cannot be used directly, but if it is directly discarded, it is a waste of information. Therefore, let's observe the field of name a little bit, and we can use this information to improve prediction the accuracy. And take out the English part of the ticket number information, because the same English code may represent the location of the room, and the latter number is meaningless, so it is omitted. If there is only a numbered ticket number, use X to represent it. When analyzing the titles on sex, survival rate, and age, we found an interesting place. For example, the average age of the master is only 5 years old, and they are all male, and the survival rate is about 60%. In the blank data part, since there are only a few missing embarked, we will directly add the S that appears the most frequently, and the fare is only one missing, so we will directly add the average value. Next, we convert categorical data to integers and use random forest to infer age. Now, we can predict survival. So we load the random forest algorithm to predict the survival rate. Next, let's conclusion. In this report, learn more about how machine learning modeling works. Most of the time, observe at the data and extracting features, such as the impact of ticket price, men and women on survival rate. Finally, find a suitable algorithm to improve the accuracy of prediction. Thank you for your listening.